Hello guys, myself Gautam. This is SIT 310 Robotics Application Development. So in this presentation, I will discuss about the project that I worked on for this unit. So I will explain you what I did and what are the problems that I encountered. So let's get started. So first of all, like ROS. So ROS is like Robotics Operating System. So this is basically an open source operating systems. It provides you all libraries, all the things that you require when you're working with robotics application. So this provides you an environment in which you can actually work to develop the robotics applications. So now the question arises, like, why do we use ROS? Like, what's the main reason why we use it? So the main reason like we use ROS is it set the standard for all the developers. Like when they are writing the code, they can't it just set a standard, so we don't need to write again and again the codes. When we're working on a big project, we can use some of the codes that are from some other developers. So in this way, ROS helps us a lot in the reusing of the codes. And the languages that we mainly use for robotics application is C++ and Python. So now let's jump into autonomous vehicle. So what an autonomous vehicle is? So autonomous vehicle is basically a vehicle that is capable of moving on its own. It doesn't need any human interaction, like or any pest or any driver, those who need to control it. It can just control by itself. So that's the definition of an autonomous vehicle. So problems with autonomous vehicle. So there are mainly three problems that I encountered when I was working with autonomous vehicles. So the first problem was the vehicles are getting all the data from the sensors. So sometimes sensors give us faulty readings, so which was a big problem. Another problem that I come up with was how these autonomous vehicles will know what's their exact position, like on which axis they are moving. And the third problem was like how will they filter all the readings that they get from the sensors so they can make a decision. So these were some of the problems that I encountered when I was doing a research for autonomous vehicles. So this is my current setup for the autonomous vehicle. So as you guys can see in these images, like these three are my ultrasonic sensors. And with the ultrasonic sensors, I have used one Bluetooth module. And just beside the Bluetooth module, I have used MPU6050 sensor. So these are the requirements, these are the stuff that I used for this project. I used three ultrasonic sensors, one MPU3050, one Bluetooth module, one Sumo robot, Arduino, Raspberry Pi, breadboard, and chip wire. In this image, I have shown this was the image that I made for myself, like when I was doing the connections, and this was for the ultrasonic sensors. And in the another image is the this is the graph for MPU6050. When I was doing the connections, I made these ones for as well. Now let's jump on to our first problem. So our first problem is like initially when I was having the issue, I was having issues with ultrasonic sensors as I was getting data from three ultrasonic sensors at the same time. So we know that sometimes sensors give us faulty readings. So it was really hard to believe those readings as our vehicle is going to take the decisions according to those readings. So in order to come up with a solution, I have used Kalman filter in my code. So what exactly is happening in my code is like in my initial code, what was happening, like we get the readings from the sensors and we will just and our robot will act according to that. But now in this code, like with my solution, I came up with Kalman filter. So what's going to happen is like when we get the readings from our from the sensors, it's not gonna just like straight away apply for the robot. Firstly, we're gonna process the readings, like is it a correct reading or not, like is it a faulty reading or not, and then the basis of that readings, our robot gonna take the decision, like is there any obstacle on his way or not. So this is the main idea behind the Kalman filter. So as you guys can see in my snippet as well, so I have applied the Kalman filter. So what's basically happening in this snippet is like when we get the code, like filtering the readings of the sensor, so they will store the readings in these ones. Like I have created like a raw sensor value. So this is the value, like this in left sensor, center sensor, right sensor, my raw values will be stored in these ones. And after when we get it filtered, so here will be like the filtered sensor value. So like in left sensor Kalman, that would be my filtered values for the ultrasonic sensors. So as we can see, like I firstly stored the raw sensor reading when it's coming from the ultrasonic sensor. Then I apply the Kalman filter and other strategies in order to get a precise reading. And after doing the filtration of the reading, we can accurately decide like is there any obstacle or not. So that was the that was my first approach for this problem. Now just jump on to the second problem. So the second problem was, like, when you're working with the Zoomer robot, I know this number of problem as when you give command to robot to move to a certain fixed path, sometimes it doesn't do what it is supposed to do, as there are numerous factors such as it might be some problem with navigation stack, etc. This was a big problem as our robot needs to know like what's the exact location of that. If any user wants to go to a certain destination, then it has to cover a fixed path or fixed location. Yeah, so that was a problem that I encountered. So in order to overcome this problem, I came up with one solution. The solution that I came up with was using another sensor. So the another sensor that I used was MPU60. So the main reason for choosing this sensor was because it has both accelerometer and gyroscope. So these both things are embedded in a single chip. So that was my main reason for using this sensor. So I used this sensor, as I already mentioned, that because it got accelerometer and gyroscope embedded inside a single chip. So with the help of addition of this sensor, now my autonomous vehicle know exactly what's the location, and it improved the performance of my autonomous vehicle significantly. As now we have considered the readings of both gyroscope and accelerometer, with the help of which our vehicle can move more perfectly, because now my vehicle exactly know what's the location of it, because it got the reading of both gyroscope and accelerometer. And when we're gonna compare both readings, we can actually know like on which axis is it actually moving. So here is the snippet of it as well. So as you guys can see already in this snippet, like we can read the values of gyroscope. So in this code, actually I'm reading the values of gyroscope, and on the side by side I'm also reading the values of accelerometer value. And after that, when we're gonna do the comparison of these both values, then only like my autonomous vehicle will take decision like on which axis is it actually moving. So in this way, like, you know, my vehicle will all the time will know like what its location, on which axis is it moving. Like suppose if I want to go to point A to point B and it is in x-axis, so with the help of these sensor, my robot will go to point A to point B in the same x-axis. So these were the main reason like I used this sensor, and with the help of this sensor, I overcome this situation. I overcome the problem that I was already having initially. So here is a snippet of my code. As you guys can see now, you can read the values of both gyroscope and accelerometer. So in this way, we can effectively deal with this problem. So these were some of the problems that I encountered when I was working with autonomous vehicle, and we have also discussed the solutions of it. Thank you and have a nice day.